Hello. How's it going? Uh, I'm just gonna check that my audio is good. Uh, wait, I think my audio is going on from the speakers. They need to be from my headphones. So have key. So now now I should listen. I think my audio is going on from the speakers. Now it should be louder from my headphones. So have key. So now I should listen. I think my audio is going on from the speakers. Now it should be louder from my headphones. So have key. So now I should listen. I think my audio is going on from the speakers. Now here I'm gonna edit this. It's gonna be 39. So have key. So now 39. Here I'm gonna edit this. It's gonna be 39. So have key. So now 39. Here I'm gonna edit this. Alright, so it's excellent. Okay guys. Now because we finished this other course of AI engineer for developers, now we need to study 3 things. One of the things it's studying about data structures and algorithms, but already the advanced part, because a few months ago I finished this course on this data structures and algorithms, but now I'm gonna go like more advanced, so I will try to become an expert in data structures and algorithms now. That is gonna be one stream. Then the next stream is gonna be about system design and architecture, which is gonna be another course that I'm gonna buy. And then the last one, the third stream, is gonna be about the ML engineering, which is already about like fine-tuning models and more advanced concepts. Probably I will need to touch deeper things on math and statistics. So yeah, that will be pretty each. And I will do these 3 streams, and I will do like intercalated. First DS and algorithms, then the system design and architecture, and then the ML engineering, and I'm gonna be doing all over again, like sequentially. Probably I will add a 4th one in which I will show you my work, because this is the thing that I'm doing in the meantime. I'm doing my work in Platos. I mean, while my tokens reset and everything from Cloud, Gemini, and the other ones that I use. And probably that will be the fourth streaming that I will do, and then nothing else. Then I will send someone to clip my streams. So yeah, so let's start with these data structures. I think I'll review this part, a difference array. Oh, this one no, this one no. I will check now this tries. Just in case this stuff I did in JavaScript, but now the thing that I'm gonna be doing is like the same, but in JavaScript and in Python. So try. It says it's just in case to the whole screen. Yeah, it's good. Whole screen. Alright, a try is a tree structure as known as a prefix tree. Usually a try stores characters of a string at each node. All paths from the root to a node represent the string of characters of the path. So each node represents a character, and a root represents a string of characters, so a group of characters. Okay, yeah, if this is A, X, H, X, H, this is the root of here. Tries can be used efficiently to implement string search matching algorithms. Okay, let's say you have a huge list of words and a stream of characters. Like someone typing building a tree, you can keep track of which words have the characters as prefix. Okay, yeah, this is one way. The following code can be used to build the tree. Okay. So in JavaScript it's like this. First I will do it in JavaScript and then we will try to also do it in Python. Uh, because Python is the newest part for me, I guess. So here you have the constructor, here you have the data, you have the children, it's a map. So, okay, in order to build the tree, you have the words, and then for cons, word of words. So we're creating a node here, which is here the current, and then constant word. So for each character of the word, if okay, if the so we are here in this part, right? This part here. If there is no any children who has that character, then we should set current children. We should set in this set, because this is a map, we should set the character C with a new try node. Okay, so we are appending the C. I mean, this will be the children is a map, so we will be setting the C to a new try node. Okay, so then current children get okay. But if it doesn't exist in the map, I mean in this map, we should get the current. Okay. So then we should go to the next character, which will be the second character. And then we should do the same with the second character. So we should do second character, it doesn't exist, then we do the same. Okay, I got it. So basically, for example, for the next word, if let's say there is like another word that is like AX, but with not H, but with another word, we don't create another path, but we just like have the same here. Okay. Okay, so it's optimizing the the space that you're taking. We're gonna try takes on times k, where n is the length of the words. Yeah, which will be basically the biggest length of all of the is the average length of the strings. Okay, so it's the number of words and the average length of the string. Yeah, in the biggest case, right? Because if it's the smallest case, it wouldn't be like that. I mean, if all of the words are the same, then we will just have like on and no. Well, if I do the, for example, let's imagine that if I will have like AX two times, then in the next word is gonna be the, it already has, so it will be like the same. It already has, it already has, so it already has. But anyway, I will need to run it again. So yeah, I think it will be O and K with this, the length of the words, and K will be the the average length of the strings. What's right? You can implement very efficient string search algorithms. Okay, so it will give you all of the options that you have there. Mm, yeah, so for example, if I'm looking for a word, I can find it there. Or, but okay, so far, if it wouldn't have a partial wording, we wouldn't find that. Okay, so search suggestion system. You're given an array of strings, product, and a search word. It's an assistant that suggests at the most three products names for the products. Wait, just in case, I'm gonna tutorial Firefox data. Okay, I'm just gonna share this, and the reason why I'm gonna do that is because I need to. I haven't prepared like my code base to share like what I'm doing in Platos, so I don't wanna like mix some stuff at the moment, you know. So because what I want to do is like after take each one of these lessons, just make sure that I just don't learn this for the passion, because I just don't do that. But I learn this, and I the next question that I ask to myself is like, okay, how can I use this in my software or in the companies that I work, or in the projects that I have, or in the solutions that I can provide for my clients. That's the whole point of all of this learning, not just because of the passion, but that's my point of view. Each person has its own point of view on this kind of topics. Okay, so let's go back to the screen here. So here again, our strange is word sensitive suggest the three most three prog names from progs. After each character of search word is typed, the three most prog names from progs. Mm-hmm. At most, three prog names from progs after each character of search word. Suggested prog should be share a common prefix with search word. Alright. If there are more than three progs with a common prefix, choose the three with the common prefix, the three lexicographical minimums. Return a list of suggested products after each character of search word is typed. So, for example, a search word is typed, a prefix is formed. Search word is A, B, C, D, E. Then prefixes after each word are A, B, A, B, C, A, B, C, D, A, B, C, D, E. Okay, for each prefix we need to find up to three of the lexicographical smallest words from the product that share the prefix. Okay, the brute source approach will be to iterate over products for each product and check which ones match. This will have a type complexity of n is the product's length. Per each one I will iterate. The per each, or I will iterate the M will be the search word length. It will cost us ON times K, which is the average length of the product works, times the N, which is the length of products. Is the total number of products that we have, where K is the average length. Okay. And then we could find all the words with matching prefixes with OM. Because K is the smallest. Because K is small. What's K? The average. Okay. It's time complexity O of O of ON times K plus M is much more better. But why would it be like OM? Like that would mean that it will be like linear with regards of the. Okay, I understand that the cost to build a tree is ON times K. Then we'll sum the OM in the search, but I don't know why it's OM. It's like linear regarding the length of the word. That will represent the empty string. We can use attribute suggestions to store true products that should be returned. To stay in line with the broadness constraint, we will limit the size of tree and keep it sorted. Okay. Once the tree is built, we can traverse the tree by starting on the root and iterating over the search word. Okay, is here an explanation or no? Okay. First I build the try. There is no audio. Yeah. But that will mean that package was banner. So if I go inside of that, but that will mean that in each note we will need to save the words. And as far as I see here, I'm not saving the data. But in this problem, because this is not how. Yeah, I mean, okay, okay, I get it. Because then when I iterate it, first I go to B and I yeah, and assign the words that are there. Okay, okay. Okay, so this this can be pretty useful for make a search of like a word search of like limited amount of products that I will get. For example, in a place that I don't need a semantic search, but I will need just keyword search. Or if I will just need a as a first as a fast return as keyword search and then a semantic search probably. So and this will be in a place that my database will be super small, like a shop inventory or like items that I will have at home. It will, I don't know how it would it be implemented in a huge database, but for small searches, probably it can help you to iterate pretty fast instead of making a brute force search. Unless there is a built-in function on JavaScript that already does that. It's protein for the muscles. Well, I'm already streaming 22 minutes and I haven't even started a problem. Okay, so per each product, I'll create. Yeah. So this is what the thing that was missing in the upper part, which is like in the node. In the node where the character doesn't exist, we put a try node and we push the suggestion, which is a product, and then we sort it. Well, in this case, this sort, I don't know how well optimized is this. Then if node suggestions is bigger than 3, node suggestions pop. Mm, so we will just keep. So we will just keep the smallest ones, and we don't care about the biggest ones for this particular case. Mm, okay, and then to make the search word, no children has. And then we push the suggestions. Then we go to the I mean, if there's, yeah, we'll just like return like nothing. Then there will not be nothing. So I will just answer the same and same and same. But in this case, I will get the Yeah, in this case, I will just like go into the child node, then I'll get to the next child node. But I already built the try with the suggestions, so okay, good. I got it. I understood it all. This is it wasn't that complicated. And actually, thank God, thank God, it's gonna be useful right away. Because I hate when I learn something and I cannot use it like right away. I'm like thinking, in which project can I just put this like new learning? This is my way of thinking. I don't like to learn something just for the fact. Except if it's math. If it's math, yeah, I just learned it because YOLO. All right. So as you see, I haven't solution. It's this is a 5-star problem, so it's super complicated. Let's see. Try. It's a tree that structure is definitively stored through keys in data set of strings. There are various applications of this data structure, such as autocomplete, spell checker. Mm, all right. So implement the try class. Initializes the try object. Uh-huh. Void insert inserts a string word into the try. Okay. Search returns true if the string word is in the try. Okay, and then false otherwise. And it starts with there is a previously inserted string word, has a prefix, and false otherwise. Boolean starts with string prefix. Okay, so for the search, we need to search if the word is on the try. So we need to make sure that the whatever we search, like we need to jump after each, and then when we but for this I just need to find like for the search I just need to go into each child, I think. So if I find it, if I get, I just return the child node, and then I just go into the child again and again and again. But what if, but if I insert a word and because the only issue that I have here is like, for example, if I will have a word that is like carousel, and inside of that tree there will be a car, but car is not part of the car is not part of the it's not part of the try. Boolean starts with, I have the same issue with this one. Returns true if there's a previously inserted string word. Mm, so first I will just initialize, and then I will output this. So the constraint is that the word length is bigger than 1 and the prefix length is more than 2000. The word number consists of lowercase English letters and most 3 times the 10 to the 4. Constant data will be made in insert, search, and start with. Okay, first let's just create this. So basically, like if I do children or in JavaScript, okay, it will be new map and bar node mm, wait, if I will do an insert, it will be bar node, it will be an object, and then I'll just do my best try, okay, and now that children it's equals to children. All right, and then I will just do the insert. Will be for import and then okay, so I assume that I will just put like this. Smaller children is equal to children, and then if current the children get, because the children see, then current it's equal to this point node. Mm, it will be this dot note. So if the children is not there, is there, the current will be this dot. Okay, this will be bar because they will variate. Children dot get dot c, in which in that case I will get the children node. And if not, set, and it will be the character and new try, and in this try I will have might be useful to set the character. I'm not sure. I will just leave it for the moment there, and I will just save there the new try. And then the current will be the so I just need these children. I don't need this. No, yeah, I need, of course, yeah, because then I don't know any reference there. Okay, so children.get. If not, I create a new try. I set the character as the new try there with C, and then I just go all over there. Okay, then on the search, I think, how long I'm here? 34 minutes. Okay, on my search, I think I will need to foreseen word. I will need to if Oh yeah, so I need to do barcode this. Core the children. And then if at some point it doesn't get, then I will need to return false. So that means that if at some point in one of the searches in one of the iterations I don't find the character, that means that I will return false. And I assume that it's kind of the same, I assume. But in this case, it will be. Okay, so for the prefix is good because that means that, yeah, this need to be the complete word, but it will need to be like at least some part of the word. Mm, but in the terms of like inserting, I think I need to save the value of the word like there. So for example, if I do the insert, so I set the new try, should I get C? Yeah, but then if in this place current that val, it's when I make this last insert here I need to put the C if word ends with C, then I need to put the current value of that, it's the word. So then I know that that word ends up there and there is a word, because if there is nothing, that will mean that I didn't find nothing. And then I will need to put in the prefix, okay? But in this case, I need to get the C. And in this case, here I need to do if a word ends with C, then and cur value is different than the word, then we need to return false too, because that means that I am partial is there, but the word is not correct, right? So let's just run it and let's see what it gets. I guess that I have some errors here in the yeah. Well, I need to I'm gonna one second. I'm gonna do this in how to do it so in the way that you don't see. Okay, give me 1 second. I'm gonna do cloud. And then I assume that now you can see, yeah, that. I need to check first the proper loop in JavaScript. How to do it proper. Characters forward. Ah, so it's a for const c of. Okay, no, this is good. I should do the same here, but with word. Yeah, and for const of. All right, let's run it. Foreseeing what? Wait, what? Here. So the map, we can just start with the object. Okay. Cannot read properties of undefined. So here in the line 16, children doesn't exist. So that means that now let's do this. In the line 20. Current children's. But how come? Okay, I'm gonna put this code into Claude. To check all of these errors and also the problem. Because if I'm gonna try to inspect each one of these codes, it's gonna be like a freaking mess. Meanwhile, I'm gonna put some of the ah, yeah. So I need to do new try note here. Or yeah, I need to do this get C and get the note. So in the next one, the coordinate is the note. Yeah. Okay. So what about? Or it's not the last character. Okay, or the value. Okay, let's pass this second approach. What about this? I fixed some stuff here regarding the this is not existing property, this val not value, and then I need to pass the current is like the node because I started this as node. Ah, okay, but the children. Let's see that node. Search and start with. So I have the same issue. So I have the same issue here. I need to that node and the same here because I am passing the node. Okay, so what about now? Mm, Okay, now it will pass, but the marker check is off by 1. Insert your test score that value before cur. Search cur the this is why the first search field is part of the word being there. But okay, because here when I insert the children doesn't have the children, but so I guess this will solve my mm, yeah. Yeah, I guess that will simplify a lot of stuff. Bar course, no. Okay, so if there is no children, then I will set a new try. And in any case, I will just move to the core. So I will just set a new try if there is no. and then I'll just move to the next node, and then we'll do the equals to word, because that will be indeed the last one of those ones. So yeah, we'll need to mm, this will still fail. So I guess that, I mean, the insert is good now, but now we'll need to fix the search and start with. But I need to figure out why would it fail. So it's shifted. So technically, if I do the um so I need to get the children. So I mean, now this should be okay. Let's test it. Search is fixed. One line left. So I guess that it starts with. So if it passes it all, I just need to return true, I guess, here. And that will fix it all, I think. Nice. So I'll now run this. We pass, guys. We pass. So yeah, now we'll do it in the Python, but probably we'll do it like later. I'll just try to finish some seat and I will take a break because this stream is, let me check, 1 hour. So we did a lot. So yeah, see you later, guys. Thank you for being here. This is the stream number 39, and now we're being expert uh, on data science and data structures and algorithms. So the next one is gonna be about system design, which is another course. The other one is gonna be about ML, and then I'm gonna come back to data structures and algorithms. So, or you know what? Until Friday, let's just do a lot of this, like um, data structures and algorithms, and then from the next week we'll just like go one. Okay, so see you later.